Okay, so we're going to go ahead and do a video class because I think we need to summarize the last chapter and the chapter we're reading this week. And I think we have a lot of questions that need answering. And I just figured this is the format to do it. And we're going to try to do it in my living room here. And I have a notepad. We're gonna try this out. Okay, so I hope everybody's doing good. It's been a really trying time for our family, and I imagine it's not easy for everybody. I mean, it seems fun staying at home, but it's one of those things that be careful what you wish for because you might actually get it. I just imagine that somebody, like, it was their birthday and they wished for summer to come early and they got their wish, and now we're all stuck at home and we can't do anything, and summer came early. So let's go ahead and get started with this. Lessons 6.2 and 6.3. So when I say that, that's Unit 6, Lesson 2, Unit 6, Lesson 3. So 6.2 is really a kind of baby introduction into plate tectonics, focuses on some plates that are in the United States area, and then 6.3 is talking a lot about what type of interactions we have between those plates. So a little bit of vocabulary before we get started. So let me check my notes here. Okay, so just some reminder, we had the layers of the Earth. There's my Earth, and on our layer, our outermost layer, we have, now when we're talking about plate tectonics, we're going to focus on the mechanical layers. So if we were in class, I would ask somebody to remind me, but we have the outermost mechanical layer, which is the lithosphere, and then underneath that we have the mesosphere. Okay, now these are the two layers that allow movement of the Earth's crust. So just a quick question, which layer, lithosphere or mesosphere, does the crust reside on? So I know you're not going to answer me and I can't hear you, but I wanted you to think. So lithosphere, outermost layer, crust. The lithosphere also includes a little bit of the mantle. Now we have the solid part of the mantle there, and then the plasticky layer, the ductile layer, the layer that has movement, it allows movement, is the mesosphere. And then, you know what? I just realized I'm making a mistake. Mesosphere comes below the asthenosphere. Oops. Yeah, okay, I make mistakes too. So, hold on. You know what? I think I can, I don't ever do this, so would you look at that? I can just flip the camera around. Okay, so we have the lithosphere, asthenosphere, and the mesosphere. The lithosphere is the hard layer that's brittle. The asthenosphere is the layer that is plasticky, ductile. The mesosphere is where we have convection. So we're going to go ahead and label that. So we have brittle, ductile, ductiles, woohoo! Mesosphere, we have convection. Okay. Now, each one of those is really important to understanding how the plates actually move. So, in lesson 6.2, it starts with talking about a fault, the San Andreas fault. How do I spell that? EAS. Okay, and that is a specific type of plate boundary, which we don't learn about until 6.3. We call that a transform plate boundary, which is when they are sliding past each other. So here's my, oh, actually I like that. So San Andreas Fault in 6.2, but in 6.3, my little squiggle there, that's a 3. We learn about transform plate boundaries. So there are some maps in the book, we can check that out. But what that means is we just have plates that are sliding past each other. So we have some earthquakes that are occurring. And if you remember from that visual, the earthquakes occur at the surface. And they're numerous, but they are usually not as powerful as a subduction plate boundary, which we'll talk about next. So not in the text, I wanted to talk about the Denali Fault. So Denali Fault, D-E-N-A-L-I, is found in the area around Anchorage and the Aleutian Islands. So San Andreas, in case I didn't mention, is in California. So Denali, Anchorage, is the reason why we have mountains, volcanoes, and earthquakes in that area. And we all know about the, is it the 9.2? One of the largest recorded earthquakes. Magnitude. Magnitude is a vocab word. Transform plate boundary is a vocab word. Plates, I guess, is a vocab word. So a tectonic plate. Spelling Tectonic plate. So we're not talking about dinner plates here. We're talking about large chunks of our lithosphere that are moving around on the asthenosphere. So just to summarize in a more simple way, we're going to call it large chunks of moving rock. So check that out. Tectonic plates, large chunks of moving rock. So those large chunks of moving rock is what causes our mountains, volcanoes, earthquake, and our large earthquake there. I just realized here, so I'm just losing my mind a little bit here. I did E-E-A-R-T-H, earthquake. So I'm going to fix that. I'll just make that. There we go. All better. So the Denali one is a subducting plate. So I'm going to draw a little map here. So we have our Aleutian Islands. And then so not the best map ever, but here's Barrow and here's Anchorage, kind of, and there's our Aleutian Islands. And what we have here is the Pacific Plate, named after the Pacific Ocean. Moving towards, now I can't remember here, but we have here in this area the Eurasian Plate and the North American Plate. So show that. So we have the Pacific Plate moving towards, it's either the Eurasian Plate or the North American Plate. But here at this line where we see all of those volcanoes and mountains and earthquakes occurring is where that subduction is occurring deep below the earth here. So there's a couple more vocab. We have subduction, Now, this is a word we should already know because we talked about that at the end of the Layers of the Earth chapter. But subduction is where we have less dense rock, more dense rock going below less dense rock. And the symbol I use for that is just one arrow going below the other. Now, that subducting is a type of plate boundary. We call that a convergent plate. So convergent plate, or convergent boundary, I'm sorry. Oh, Ava wants to help me. So we have a convergent, not plate, but convergent boundary. So this would be a plate there, but the boundary is actually where those two kind of meet up, okay? So the Denali and talking about the location of all that there is what we talk about in 6.2, and then the name of it, the convergent boundary, is lesson 6.3. So we're kind of combining two of them together here in this video. And Avit, hi Avit. Oh, he says down when he wants up. Okay, not right now, okay? Okay, let me check. So, we've already talked about plate composition in a previous one, but lesson 6.2 talked about plate composition, so that's more dense and less dense crust. And the continental margin and relative versus absolute were two new concepts. So, now when we're talking about boundaries, it's not just like a single line where they're meeting and that's it. There is a large space that counts as the boundary, and that's where we call it the margin. So in the Denali plate, for example, you're going to have, oh, don't play with that. You're going to have under the ocean the abyssal plain, slope, and then you're going to have a little bit of rising of that land until we meet the continental shelf, which is still below water. Then we get to the beach, and then you have mountains. So that whole thing is the boundary. So it's not just one line. That could span several hundred, if not thousands of miles. So I'm going to draw a little bit of a picture to demonstrate these areas here. So we have, just as a reminder, we have the abyssal plain, ABYSSAL, PLANE. Wait. PLANE would be like it's a plane, but we're looking for PLAIN, like the plains or a flat area. So the abyssal plain, and then we have some rising. What do they call that? They just in the book they just said it's the slope, and then we have the shelf. Oh, somebody's getting tired. He starts throwing things when he's tired. No. Okay, so I starred the two words that you probably haven't learned before. We have abyssal plain and we have the shelf, or the continental shelf. So underneath here, I kind of demonstrated what's happening below the surface. So we have one plate subducting, and then we have one plate that is on top that is causing earthquakes deep, deep, deep within the crust here. And so this is going to cause not only earthquakes, but volcanoes and such. And those are going to occur on the continent itself here. And that's where we see little islands here popping up. And then we also have some volcanoes here in around Anchorage, actually. So abyssal plain, and then it's rising shelf. And again, this could span hundreds, if not thousands of miles. So, oh, he shut down my computer here. Let's see here. The other thing that they said in there, which was a little odd. My goodness. Turn around for a second, he's drawn all over it. Is relative versus absolute measurement. So we have learned that GPS in this chapter is what we use, and that gives us absolute data. This is measurable data. But relative data is just kind of a summary of that absolute data. Okay, so GPS gives us absolute data, which is measurable, and relative is how we summarize. So like when I say that transform plate boundary is moving side to side, that's relative. But sometimes we can get a little bit of motion that goes towards it, and that absolute data might show us that, but on the larger picture, we're going to see that side to side motion. So here we have just my little drawing, simple and absolute data. So absolute data, you have lots of different types of movement going on in an area, but our simplified or our relative is just showing two lines coming together. Okay. All right, so that's really most of, if not all of 6.2. And then 6.3 is just really focusing on naming those plate boundaries. And I'm going to I think I'm going to throw in a little extra just for fun for this next part. So I'm going to pause the video and we'll start back up with just focusing on the plate boundary types. Okay, so took a little bit of a break to go ahead and write through all this stuff because there's a lot of drawing that helps visualize the boundary types coming together or pulling apart, whatever it is. So let's go ahead and see what beautiful things I've drawn on here. And also to clarify, there are a lot of really great videos on YouTube that do this a lot better than I do, but friendly face, maybe that'll help you. I don't know. So let's start here with my song that I learned in 7th grade for doing this. So we have convergent boundary is colliding, coming together. Divergent boundary, dividing, pulling apart. Transform boundary. You see here I have a D, dividing, C, colliding, but transform goes into sliding. How does that happen? I don't know. Transform means change. So Transformers something, maybe this is where the Pacific Rim was located, I have no idea. So but that's sliding, we have them going past each other there. So let's go ahead and sing the song. So ba 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 bump, ba 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 bump, ba 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 bump, ba 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 bump, ba 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 bump. Convergent is colliding, divergent is dividing, transform is sliding, these are the boundaries. Convergent is colliding, divergent is dividing, transform is sliding, these are the boundaries. Ba-da-da-dum. All right, so now you'll never forget them. There's 3 main boundary types. Now, these are not that simple. Sometimes we're going to have divergent boundaries that are causing transform boundaries and convergent boundaries. But when it comes down to earth science in high school, you're not all going to be geologists, and that's fine, but I think it's important that you know these 3, and so does the rest of the world. So let's go ahead and try to memorize those. So let's go with convergent boundaries first. This is probably where I've spent the most time. This should be reviewed because I think this is such an important part that we should be revisiting this time and time again. Now, this drawing that I've done here should look kind of familiar. Here we have our lithosphere and our asthenosphere. Remember, lithosphere is the brittle, asthenosphere is the ductile or plasticky layer that's going to allow that bending of rock so that it can go underneath there because it's a little bit warmer. And it's going to heat up so much here that we have a number of things happening. Now, we have volcanoes, of course, hot spots. That's where we got our Aleutian Islands from the Denali plate boundary. The stuff here on top, the continental crust, is less dense, if you recall. More dense crust goes below. Surface features that are caused by the subducting plate by our convergent boundary is a trench, and again, our volcanic arc, mountains. So there's some things that we need to know. So with our divergent plate, it gets a lot more simple from here on out. This is probably our medium complication one. Divergent plate is dividing. That means it's pulling apart. So here we have, this is my magma coming out of the earth. You're going to find these usually on the bottom of the ocean floor. So the Mid-Atlantic Ridge, named for the Atlantic Ocean. Is where we're going to see probably the most well-known version of this. You have very minimal, you have earthquakes, but they're not as strong. So we have two names for these. Spreading ridge, this is what we see on the bottom of the ocean, and we have a rift zone, or a continental rift zone. This is like a popular one that you'll see is in East Africa, is on the continent, and you do actually see the rift zone there. And in our book, it talks about magnetic reversals, which doesn't really, help us understand so much the divergent boundary, but is a really cool part of why it's important to explore our world. We learned, going to the bottom of the ocean, that we're seeing magnetic reversals. Here I represent it with pluses and minuses, but magnetic reversals, meaning that once the Earth was pointing north, or the magnetic pole north, where we're at, was north, but then it switched in the past at some point to south, and then even further back it was north again, and that pattern repeats itself on both sides, and we can actually start to age when these magnetic reversals occurred. And scientists have theorize that this is going to happen again, because it just throughout history happens over and over again. And so there are a lot of doomsday people that think, okay, that's going to happen and it's going to ruin everything. Birds are going to get confused and all this. And yes, that's possible that some bad things could happen, but the Earth has survived and life has survived so many times. This has happened over and over and over again. It's really unlikely that it's going to be a doomsday scenario, but people like to make clickbait, don't they? So go ahead and enjoy your clickbait. But in science class, we don't have room for doomsday. We just have room for oohing and ahhing over the beauty and magnificence of our Earth. Anyway, so I was saying here how this isn't always pretty in nature. We have the three types here, but kind of an interesting point I want to make here is that a divergent boundary can cause a convergent boundary here. So here's my little image to show that. So here we have the boundaries, or the Earth pulling apart, but as this part is pulling apart and this part is cooler or more dense, you're going to have some that are coming together here, forming a very small convergent boundary. And on the bottom of the ocean, you can actually see kind of these wrinkles here outside of a divergent boundary on both sides, because it is causing a little bit of a convergent boundary there. So, once you get your head wrapped around it, it's not too hard to understand. But at first, maybe these words, because they sound so similar, convergent, divergent, it can be a little bit confusing. So, transform, though, is fun, because not only is it an easy word to say that doesn't sound like the other ones, it's actually I think pretty easy to understand. You just have plates. This is areas where the Earth, those slabs, those tectonic plates are sliding away from each other. Okay, you're going to get areas where they're going to crash into each other, and then we call that a convergent boundary or a mixed boundary or whatever. But for now, for Earth science, you just need to know that transform boundaries are sliding apart. Now you're going to get lots of earthquakes here. You're probably familiar with all the movies that you see from Hollywood where you have earthquakes occurring in that area. That's because Hollywood is right by the San Andreas Fault Zone, right on it. So they're going to do all kinds of things with that. But we got the cool Denali Fault Zone, which I think comes with lots of extra fun things. So going from there, we're going to do an extension here. I don't think the text talked about this, and I'm a little bit surprised. Maybe it does somewhere, and I just didn't see it. But a hanging wall and a foot wall. So when we're describing these plates, you have a bird's eye view, and then you have a crosscut or a side view. So here is an example of a divergent plate here. And here's an example of a convergent plate. But what do I mean when I say hanging wall and foot wall? Well, when you have a plate that's moving apart from each other, one plate could be sliding down while the other one is sliding up, or maybe the footwall isn't moving at all and it's just this one moving. But it helps us visualize a little bit the movement from a sideways angle, so we can start to see how the earth is, what's going on below our feet. Now, I drew this funky dude here because when I'm saying footwall or hanging wall, this is really easy to confuse. But if you can just remember this terrible drawing I made, a footwall is always going to kind of look like a shoe. So you don't wear your shoes upside down here in either of these. So those are our hanging walls. And our footwall, regardless of where you put it, is always going to look kind of like that shoe there. So there you go. So in this one, our hanging wall is sliding down the footwall, and that creates a divergent boundary. And here we have the hanging wall moving up the footwall. That causes a convergent boundary. So if you take earth science, or not, you wouldn't take earth science in college. It would be geology or different types of geology. You're going to talk a little bit about hanging wall and footwall, and I hope maybe that can just sit there and stew for a couple years before you become a world-renowned geologist. That this will help further your understanding. So, trying to think if there's anything else I need to wrap up. That 6.3 I think was a pretty easy chapter. There's a lot of really cool information in there. I really like the ebook. And in my next video, I'm going to explain some common issues that we're having with the ebook, and maybe we can resolve those. Okay. So if you made it all the way through this lecture, great job. It was. I'm looking at my timer here. It says it's 26 minutes. Now, class is 40 minutes. I usually don't do this much talking. I'm glad you were able to do it. Maybe you read the chapter and this was just a really good way to clarify everything. Maybe you didn't read the chapter and you just want to know what the heck's going on. That's also cool. So this is basically covering 2 weeks worth of work. So one lecture for 2 weeks, 26 minutes is not bad. I'm gonna say I think you got a good deal on this one. Now the first week was really review, was layers of the earth. If you didn't get that done this week. It's just 5 questions every week that I'm asking. You pick the questions from lesson self-check at the end of each lesson, and hopefully I'm making it just the right amount of difficulty for you, so it's not too difficult, it's not too easy, and you have enough time to do work in all of your other classes. Okay, so it was good talking to everybody. I will see you next year.